This webinar is sponsored by NEC Corporation, a $37 billion global technology leader with over 100 years of innovation to empower people, businesses, and society. NEC's ProgrammableFlow Network Suite, the subject of this webcast, was the first commercially available enterprise-class SDN solution to leverage the OpenFlow protocol, enabling complete network virtualization and allowing customers to easily deploy, control, monitor, and manage multi-tenant network infrastructure. In addition to simplifying network administration, NEC provides a programmable interface for unifying the deployment and management of network services with the rest of IT infrastructure. Thank you for your time and interest in NEC's ProgrammableFlow Network Suite.
This sponsored webinar is one of many IP Space Data Center webinars. You can register for live sessions, buy the recordings, or get access to all of them with a yearly subscription. For more information, visit ipspace.net/DC. Welcome again, and the topic of today's webinar is NEC's ProgrammableFlow, and we'll try to go as deeply into the product and feature set and all the dirty details as you wish. And to keep me honest, I have Samrat with me on the webinar. And Samrat, please tell us what you're doing at NEC.
Hi, this is Samrat. I am the Chief Architect in the NEC's ProgrammableFlow division, where I lead mostly the solution architectures, working with different customers as well as the product group. And I have been in this since NEC started in the OpenFlow space. Before that, I have been coming from a research background in NEC for a long time in the area of networking and distributed systems. So my focus here is mostly in the software-defined networking architectures as NEC develops it, and then trying to find out its use cases both in enterprise data centers as well as the carriers, tier 1. Plus, we are also delving into the whole OpenStack world and how it connects into the software-defined network space.
I'm Ivan Pepelnjak, and unfortunately, I've been in networking for too long, so I've seen almost everything there is to see, although some things still surprise me. I was first technical director in my company, and later I moved into what I call Chief Technology Advisor role. And lately, as you know, I'm doing a lot of blogging. I am developing webinars. I wrote a few books, and I'm doing some occasional consulting. On top of that, they persuaded me last year to start teaching scalable web application design course at my local university, and they managed to persuade me to do the same thing this year. My focus in the recent years, primarily large-scale data centers and network virtualization, and tied to that, network solutions for cloud computing, primarily infrastructure as a service cloud computing, and all the other things that sort of naturally come out of that, like scalable application design and things like IP routing or IPv6 with MPLS and VPNs. And now let's move forward, and we'll start with ProgrammableFlow principles of operation. The first thing we need to cover is the very basics of OpenFlow. If you need to know more about the details of OpenFlow, I would strongly recommend that you go and watch the OpenFlow webinar we did last year, because it does contain all the details what you need to know. The basic principle is very simple. In today's switches and routers, these devices act independently. Every single device in the network would run its own control plane, like this one here and this one here, and then they would exchange data between themselves, and every device on its own would then calculate the paths around the network and install those paths in its routing and forwarding table. So the networking devices are totally independent, they are on their own. Not so in OpenFlow. In OpenFlow, the control plane runs in a central controller. And that controller can be either an independent appliance or a server, or it could be built into one of the networking devices, and it would do all the control plane functionality. The devices themselves would only do forwarding and some maintenance function like keeping track of which ports are up and down. Of course, if you want to do this, you need some sort of communication between the controller and those devices. That communication is done through TCP session, and we're using a special protocol called OpenFlow protocol. For security reasons, these TCP sessions could be encrypted with standard encryption. You can call it SSL or TLS, the same thing we're using with HTTPS. Now, the moment the device is connected to the controller knows that there are that many devices out there, and it can build topology of the network. Before going there, let me mention one other thing. You might want to establish these control sessions over the data path, so over the same links as the user traffic will be going through, but that's not very reliable, because if you hit a software bug somewhere, you could cut the controller off from the rest of the network. So it's better to have an out-of-band control plane network whose only functionality is to provide the connectivity between the controller and the switches. And so the controller builds the topology of the network in its software, and then the controller knows where, let's say, individual MAC addresses or individual prefixes are. So let's say we have a prefix B here, and on traditional switch, you would configure the subnet here on the switch interface. In the OpenFlow world, you would actually configure this prefix in the controller. So you don't do any configuration on the individual switches. You do the configuration in the controller. And then the controller, based with this subnet information or MAC address information and topology information, figures out what information needs to be downloaded into individual forwarding tables in the switches. And the forwarding tables could be simple layer 2 or layer 3 forwarding tables, which could match on source or destination MAC or IP addresses. Or some switches use richer matching tables called TCAMs, ternary content accessible memory. These are tables where you can do lookup based on a number of fields like source and destination IP address, source and destination port number, source and destination MAC addresses, and so on and so on. So TCAM gives you rich matching functionality that you can use to implement layer 2, layer 3, even layer 4 based forwarding. And so the OpenFlow controller would download the information into individual switches. And in our case, it would download the information that B is reachable here in this switch, that B is reachable over this link in this switch. And here you see the controller would know that this switch has 2 equal cost paths to prefix B. And so it would download 2 equivalent entries into this switch and thus enable equal cost load balancing. If you have questions after watching this video, send a tweet to @iOSHint or send me an email using contact form on ibspace.net, where you'll also find information about other data center webinars. For all commercial questions and programmable flow evaluation requests, please contact NEC.